Good morning, everybody. My name is Spencer Scheffler. I work in the Azure Stack team, and I'm responsible for the hardware architecture for Azure Stack and how we think about scalability, capacity planning, and work with our partners to bring solutions to market. So, the goals for today, so I've done architecture talks in the past about Azure Stack, and that material's online. Some of today will be a recap of that, but with the intent that we're actually talking about giving you enough information you can understand how things are put together so that when you think of purchasing an Azure Stack solution, then you have kind of the right tool bag and tools that you can go ahead and have an effective discussion then about what you need to purchase and the size, capacity, et cetera with that. So hopefully you're in the right place for that discussion today. At the end of the session, what I'm going to be doing is walking through essentially an Excel spreadsheet that captures the business logic behind what I'll be describing, at least parts of it. Giving you an example of what that looks like. The intent is that we'll be releasing that in October. Our partners, solution partners, have this material already and have built their own kind of sizing calculators and the tools that they need to help their customers through it. But we'll be having essentially a generic one that you can get your hands on and kind of think about size and scale, and we'll be updating that as the product progresses. So just to kind of give you a teaser for the end. I also have 4 t-shirts like what I'm wearing today. So got 2 extra larges and 2 double XLs, and if you ask a question at the end, you're one of the first 4, then you get a t-shirt. So that's the other incentive to stick around and not walk out the doors. Okay, so I have a few questions, so I need to kind of get a feel in the room of kind of what knowledge you have and kind of what level I need to kind of start at and cover topics. So does anybody here actually attend last year's architecture talk that I did? Show of hands. Thanks for coming back. I know it looked probably pretty painful. The second question I have is who in the room has actually used Azure Stack software development kit, actually loaded it and used it? Excellent. Excellent. Who's been attending other sessions about Azure Stack this week? Who's going to mark on their response form that this session is your favorite? Nice. I'll remind my manager about that. The other question I have, since a lot of the material that I'll be discussing essentially is around Windows Server 2016, because that really provides obviously the foundation of what we're building on. So who in the room actually has, say, storage spaces direct knowledge or utilization? You're actually using it or at least aware of it? Okay, and the software-defined networking stack at all? Nice, okay, excellent. That gives me a good feel. Thank you. So just a couple of quick slides to set context of kind of how we think about size and capacity. You will have seen these next 4 slides if you went to any of the other sessions or kind of common material that we have that we're sharing amongst ourselves. So obviously we're building consistency in the context of capacity planning. Consistency means that you have to think about the VM SKUs that you're going to deploy in Azure Stack, just like you would in Azure, same sizes, they apply to Azure Stack. And the same types of things around storage. Now I'll cover some of the delta differences, but think of kind of storage accounts, containers, et cetera, will be the same. So programmatically, obviously, we're trying to work to be consistent. So in the context of capacity planning, that's what you need to think of. The other thing is that building applications, one of the motions that we're working, as we talk to people and work with them, we suggest that they start with Azure, work with their application to get a feel for kind of how it's going to scale, what it's going to look like, how they want to put it together, and then they can use that knowledge as they apply that to size and capacity planning for Azure Stack. So it's a really fantastic tool. We get to use Azure for that. You don't have to go out and necessarily buy or even POC an Azure Stack solution. You can get started with Azure. And then through this discussion, I will tell you what the delta differences are, the things to pay attention to as you build that out, so you can kind of get the right thing in place for your solution. I forgot one question I didn't ask. Sorry. So who in the room has actually or is planning on buying an Azure Stack solution? You're in the right place. And who's actually reached out to an OEM vendor and had an initial discussion? Okay, that's really good. Okay. So you've also seen this slide, kind of the what is and what it's not. My take on this slide is the very first item around that this isn't a virtualization stack. And as we walk through the material today, you'll come to understand that there are, the way we've constructed it and the behaviors for some workloads may get in the way, right? There's some bottlenecks, some structure that there's not ultimate flexibility in the platform. So if you want to have that control and flexibility, then you're really looking for a Windows Server 2016, say a Spaces Direct virtualization stack. It's a fantastic platform, it gives you a fantastic range of capabilities and configuration. Obviously, it doesn't give you Azure consistency, but there are a couple of different trade-offs. So you have to keep that in mind as you think about working to build out solutions. The other thing about Azure Stack is the second bullet point is that it's not do-it-yourself, right? So it's an integrated system. That's the way we have built it and are delivering it with our partners. And that's important for us. Let me skip through this one. Because as we think through this, it's really a partnership, right? We have to be able to deliver a system that can work correctly, will offer that consistency with Azure, will be able to be delivered quickly, so we can get it on the dock, into your data center, and up and running quickly. So that's important because that's a big piece of what we think the value is that you're taking that knowledge and experience of Azure, and you can quickly stand it up and get up and running and utilizing the platform instead of spending months and months working through essentially a do-it-yourself platform. So obviously our solution partners, we announced orderability for Cisco this week is in combination with that. So we have 4 partners in market today. Next, okay. So around the solution lifecycle, so I have kind of a longer spiel about this, but for today's discussion, what we're really talking about is kind of the hardware architecture, the solution architecture, how things put together, what are the things that we pre-provision, say, for example, in storage, what does the networking configuration look like, and then what is the impact then on the standing workloads on the solution. So that's really a big piece of that. We obviously cover all of the other points on this slide. I mean, it is that integrated solution. The other things that we have to kind of keep in mind as we move through this is things like patch and update. We do hold capacity back so that we can do our best to not disrupt workloads in a system as we do patch and update. You'll see a patch and update every month, so you'll get security fixes, bug fixes, and additional features as time goes by. So you have to think about, taking that into account because you'll take some of the resource away when you're doing patch and updates, so there'll be a little bit of disruption to the platform from a performance standpoint because you're pulling resources offline. But the other thing is that you'll actually be seeing changes as we move forward, so that meaning that we may have services that start to scale a little bit more effectively based on utilization, and we'll add additional features, right? So what I described today, say 6 or 8 months from now, may change, right? So we're actually improving that platform over time. So let's talk a little bit about the hardware requirements. If you've been engaged with the partner, you'll start to see some of these things. So this is an example, a portion of the spreadsheet. I know it's really small, but it's not the point. But the highlighted green rows really are meant to capture the choices that you generally have, or the flexibility in the overall platform. So the first thing, obviously, is CPU and memory. Each of the partners have their own certification and validation that they've done. So part of our requirements are that they stand up a SKU of the hardware they support, and they have that available in their lab so that they continually test that. So every month that we deliver a patch and update cycle, if you've gone to talk to or listen to Justin's talk, you will have heard him go through and describe how that works. They are part of that delivery so that we build out the software kit. They have essentially their OEM driver and extension kit, so it's specific to their platform. Those two things get combined and tested every month, both on our side and with the partner. And so they go through, they have to have those systems in hand. So their SKUs that they offer you will be restricted to the sets that they have that they can validate for you. So that first thing is CPU and memory. You get to choose essentially some of the SKUs and some of the memory density for the platform. Cache, so this is storage cache. So how much flash do I have in a system? What's its capacity? How many devices? Again, that will vary a little bit from SKU to SKU. Next. Here we go. Capacity drives, I'll go through and describe this later, but how does Spaces Direct, what's the capacity of those devices and how they actually stand up for overall capacity for the solution. And then obviously the last selection is that you can pick the number of servers in your configuration. So in Azure Stack initially, if you haven't already heard, we'll support 4 to 12 servers. and a scale unit. So you can pick the numbers between there. So now the OEMs have potentially chosen different kind of click stops along the way, meaning that our software will support 4, 5, 6, 7, 8, 9, 10, 11, 12 servers in a scale unit. The vendors may have chosen to deliver, say, 4, 8, and 12, and that may be aligned with efficiencies in their validation, efficiencies in the way they deliver those solutions. They may be able to essentially build in some cost savings for those platforms. So they may have additional restrictions on how things get delivered, but from a software platform, we have the flexibility there so that we can meet their requirements as we go forward. So for the network switches, when you go talk to a partner, you'll see that switches are included in the package. So you get two, at this point, I think everybody's shipping 10 gig switches. That's the minimum. So they can choose to do something different, 25, 40, 50, 100 gig switches eventually in the platform, but that's the main criteria is that we have two of those for the data path, and that there's a BMC switch for the out-of-band management and the configuration. These switches have to support the variety of kind of Windows Server 2016 base capabilities that we need, so like data center bridging if we're using Rocky v2 for RDMA, DCP, PFC, ETS, et cetera, right? So those are just kind of the technical pieces of what's there, but those are gonna be included in the solution. And then for compute and storage, each of those servers, we have a minimum number of cores that have to be in place, 256 gig of memory minimum. I think at this point, based on sizing, that's really bare minimum. You really need to have something probably a little bit more than that. A 2-port NIC, so we have connectivity to those two data switches and resiliency and throughput, performance. A local boot drive, so we have quite a bit of content that we lay down. We lay down an OS image, we lay down the patch and update image, so you essentially have two images in place. We have logging that happens locally, and then we aggregate that and spin that up into our monitoring. So we use that drive for essentially local logging content that comes out of the components that are running there. So we have a little bit of additional storage, and then we have essentially a buffer for us to capture, if and when a server actually takes a fault and we have to capture a dump, we'll have space for that as well. So you'll see that in part of the solution sizing. And then for the storage that's used for Spaces Direct, Azure Stack requires that we have at least 2 cache devices. Those can be NVMe, SATA, or SAS SSDs. And then we have 4 capacity drives. And those can be hard drives or flash. So Azure Stack at this point is a 2-tier model. We always, so if you're familiar with Spaces Direct, as many of you are, then you have to have those 2 tiers in place, and they have to be different bus types at this point. So that means NVMe to SATA, or SATA SSD to, say, hard drive. We can do NVMe to SATA SSD as well. So the platform is ready for an all-flash configuration. You'll note some notes down at the very bottom. Talk about capacity ratios. I'll go through that a little bit later, but just generally speaking, we want to see, from a raw capacity standpoint, 10% flash to a 10% capacity. So essentially, cache to capacity ratios should be about 10%. And I'll go through and describe why that's important when you think about capacity planning and the workloads you'll run. One of the other things that'll come in the package, so the servers I just described are essentially the servers that are used for the workloads that you carry in Azure Stack. That's where all the VMs will land. That's where the tenant workloads, et cetera, will land. But there is a hardware lifecycle host as well. So this is essentially just a single server that gets used for, as it says here, hardware monitoring. So each of the partners have their own out-of-band hardware monitoring capability. Windows Server and Azure Stack at this point can monitor storage devices. So if you take a fault in a storage device, we'll monitor that. That'll come out of our monitoring, eventing, et cetera. But we can't do essentially power supplies, fans. If there's a CPU fault, it may be that the out-of-band management can actually take account of that. It can actually figure out memory faults much more easily than we can within Azure Stack proper. So we essentially have 2 side-by-sides. We have Azure Stack giving you an eventing stream for the software load and storage devices, and then the hardware lifecycle host will, for each of the partners, have some external monitoring. We can also patch and update the firmware through that host. And then the other thing that its purpose is the very beginning of deployment. Azure Stack is deployed on site, so we have a deployment virtual machine essentially that runs on that host. It gets used just to lay down the first instance of Azure Stack, and then that VM is removed and taken away. So, okay. So the physical switch topology, like I mentioned, we have 2 switches, the data BMC. We're doing that for resiliency and performance eventually, and I'll go through and describe what that looks like. So for scale, if you've seen this pitch before, an Azure Stack cloud is essentially a single instance. So that means if you're familiar with Azure, you go to a portal that's actually backed by an Azure Resource Manager. So that portal interacts with essentially a service that runs Azure-wide. So it's across many regions. So the same thing architecturally is in place for Azure Stack. So we have one ARM instance. We can have multiple regions and scale units underneath that. Within a region, then, architecturally, is that the idea is that those are in the same physical location. They're co-located. And in Azure Stack, as I go through and describe the physical network architecture, you'll understand that those racks or scale units have to be reasonably physically co-located because there's going to be a pretty high connectivity in between those physical switches. And then each scale unit, the idea is that I have multiple servers within that scale unit. It gives me some vertical capacity. And again, that gives us the ability to kind of align hardware SKUs, and in the future we'll be able to deliver different types of hardware capabilities. So at initial release, again, you may have seen this slide, is that we'll be delivering one scale unit, one region underneath one ARM, so you get an Azure Stack Cloud with one scale unit of 4 to 12 servers. So all the other dotted boxes give you a case or an instance that we're aligning with Azure, generally speaking. So we'll align with region. Scale units are essentially our concept in Azure Stack, so it's a way for us to rationalize and specify kind of the hardware requirements. Within that scale unit, all the servers have to be the same configuration. They have to have the same CPU, memory density, storage device type, so type, capacity, and count. So there can be some variance in essentially vendors. So if I've got 2 hard drive vendors, but if they're the same capacity, that's okay. If I have 2 SSDs, as long as their capacity matched and their performance is very similar, then that's okay to have in the solution. So they don't have to be exact matches, but they need to be very close. Mm-hmm.
If you're adding a scale unit, does it mean you're adding to an existing configuration or it's a new configuration?
So the question is if I'm adding a scale unit or nodes or servers within a scale unit? Yeah, so the idea is, so the question is if I add a scale unit, do I add that to essentially existing capacity, et cetera? So there is flexibility. So eventually, when we deliver this capability, if I add a scale unit, I can add it to a region, so I can essentially expand the capacity of that region. Or I can add a scale unit, and it can be in a different region, so I can essentially create a new region within Azure Stack. So physical network connectivity. So obviously, each of the servers are connected to both of the TORs. They're also connected to the BMC switch for out-of-band management. So I get both ports of each server. I get the out-of-band pieces to the BMC switch. I also connect to the switch management, so the switches are also connected to that BMC or that out-of-band management configuration, so that's available. And then finally, one of the most important points is these 2 switches use a feature called multi-chassis lag. That's the generic name for it. But that allows for those 2 switches to provide a single layer 2, so that each of the servers can then create essentially a lag, when the server terms, that would be a switch embedded team. So we take those 2 interfaces and treat them as a single layer 2 VLAN in the configuration. But I'll point out that anything above those TORs is going to be a layer 3 connectivity. So anything outside or northbound of those TORs is going to be routed in the configuration, and that's a requirement. So if I expand eventually, so if you think back to kind of the architectural direction about providing multiple scale units, if I go to multiple scale units, I have essentially a copy of each one of these. So I have 2 scale units, 2 sets of switches. Then we're going to add a layer of aggregate switching. And at this point, this is, if you're familiar with the terms, a layer 3 cross network. So each of these switches at the TOR are interacting with the aggregate switches through routing. So that gives us a great scalability, so I can add more switches with a minimum amount of disruption. My broadcast domains are contained within the scale unit themselves. And then I can actually, that's why essentially we start off with routing from the initial TORs, because when we add those aggregate switches, we have to continue to route, because at that point we'll lose all the VLAN connectivity. So if the next slide's a little bit dense, so I actually have a question. So who in the audience is familiar with BGP and kind of the layer 3 configuration? Okay, all right, thanks. So when I So Windows Server software-defined networking is built with the capability of injecting BGP routes into that essentially a layer 3 network. And it does this because it's projecting essentially virtual IP addresses into the network itself. It's managing those directly. And it's the best and most effective way is to do that through BGP. And so we actually interact with the physical switch BGP instances from within Azure Stack. And so that's what this diagram captures. So the BGP ASN number is an example. So the physical switches is 22. The software load balancers, or the SLBs, there's 2 of them in the Azure Stack configuration. So two different VMs that act essentially as switches themselves, software switches, if you will. They share BGP ASN numbers, so they're treated essentially as a copy of one another, and the data can go to either one of those in the configuration. So this means the physical switches, when they go to route the next hop, they use a thing called ECMP, equal cost multipath routing, and they essentially choose which path they're going to go to. So either one of those SLBs, so it's an active-active configuration. So the SLB picks it up and then acts as a router effectively and then forwards it on to the individual VMs. So that's what this diagram is trying to capture. The idea then is that if I go to multiple racks in the configuration, as I mentioned, you add a set of aggregate switches. I'm going to cable those together. That other Tor switch pair has its own BGP instance. It's a different number because it's a different pair of switches. And when I talk about the other scale unit, it is also going to have an SLB pair in it. And it's going to share the same ASN number. So that means that those the 4 SLBs at this point act as essentially one common switch layer infrastructure. So any 4 of those can now take inbound data from the physical switches and route it within the Azure Stack solution. Then obviously the aggregate switches have their own BGPs, and you see it's kind of mirrored at the top. The 2 aggregate switches share the ASN number between them, so they too can take routing data from any of the scale units and find a right home for it. So that's how it's put together. So as we move forward, keep in mind those SLBs in this discussion, because we'll come back to essentially what that means from a performance and throughput standpoint for the solution, and we'll talk a little bit about that. So logical network connectivity, so you may see this in other sessions, but the idea is that this is what we're actually laying down in the physical switches. So each one of those colored bars that run across the display represent a subnet and a matching VLAN. So the physical top rack switches have an infrastructure subnet and a storage subnet. The storage is what its name implies. It carries all of the Spaces Direct RDMA traffic. It's what carries, the backbone of all our storage. We cordon off 50% of the physical fabric bandwidth for storage. So that's its cap. So we can't get more than 50% out of the solution when everything's busy. And then the infrastructure subnet carries effectively everything else. So that's all of the encapsulated traffic, it's all of the intra-VM, infrastructure VMs that are running, carries all of that content. So that's the second one. Then on the other side, the out-of-band network on the BMC side, then we have 2 subnets. One is the BMC subnet, so that carries the essentially like ILO or iDRAC or IPMI interfaces to the physical servers, provides connectivity to the HLH. So that HLH server is connected to each one of those servers out of band, so it has that connectivity. And then there's a switch management network as well that gets carried around, so that's separated so we can actually ACL that switch or that subnet off as well. And you'll notice within the host portion of that diagram, the tiny print, are the variety of virtual NICs that are created on the individual host, and essentially all the content that gets carried back and forth through the software-defined networking stack. And I'll come back and talk a little bit about that as well. So these are the sizes of the subnets, so just to give you kind of a context of how big things are. And Thomas Rodinger has a session at 12:30, I think, that talks about integrating Azure Stack into your data center. And it's going to be very good because he essentially starts from scratch and works through and describes all the integration points. And so by the end of his talk and demos, you'll have a sense of what it takes to deploy Azure Stack. But this is essentially some of the networking questions you get asked. So essentially, we have an infrastructure network storage and the private IP space are combined, so we actually ask for 2/24s. Then the BMC switch management are separated, so those are kind of sized based on what you think your capacities are going to be. And then there's a public VIP range. So this is the set of IPs that get used by Azure Stack to present itself on the network externally. So everything above the public VIP, that's all address space that's contained within the solution, is intended to stay within the solution for the most part. It's only the public VIPs that are intended to route northbound of the solution. So to talk a little bit about that, so we have, as I just described, so the idea is that I've already described kind of what the Azure Stack hardware and the switch configuration looks like. It'll essentially kind of cut through that and go to a custom your border switches. So that means that, again, those are layer 3 routes that are going to the border switch. So that can be anything that you might have, but the idea is that I have 2 connections, at least minimum, 1 from each of the TORs, so that I have resiliency and redundancy. Again, it's routed. It can be static routing, it can be BGP. I'll have a set of virtual IPs that are exposed, as I mentioned. And so what are those? So I kind of talked about them. So the ones that I'll list will be the things that we stand up and run initially with Azure Stack. So it's the user portal. We do the admin portal, so those have a set of virtual IPs. These are the associated host names that get stood up with them. There's a key vault and a set of services. There's also storage endpoints that are in Azure Stack. So there's ADFS and AED and Graph, depending on which authentication mechanism you're using. Then there's a site-to-site VPN. I'll come back and discuss that a little bit further, but this is one of the 2 ways that you can connect to Azure Stack. So you can either go through a set of public IPs for the user space or the user workloads, or you can come in through a site-to-site VPN. And then finally, you have all the tenants or the user workloads and the virtual IPs that they're going to stand up. So you can have multiple virtual IP pools. You start off with one, and if you run out of that space, you can add more to the system. So like I mentioned, we project those virtual IPs through the TORs. This diagram is meant to kind of walk through and talk a little bit about what the expectations are. So at the very top, there is a firewall. You have some, if you're really going to put this on the internet, then you're going to have a firewall and some DDoS protection. You're going to put this probably in a DMZ so that it's restricted. We'll give you all the firewall rules that are expected, so you can essentially start off with a deployment. And again, that's one of those things that Thomas will go over later today. But by default, we set up a set of physical switch ACLs. So I talked about the fact that infrastructure and the storage subnet and the private virtual IPs, the things that we use internally, Azure Stack, are meant to stay internal. One of the ways that we enforce that is through the physical switches, and we set ACLs on those switches to restrict that traffic. So if somebody tries to go outbound or inbound or communicate between some of those subnets, then we block them at the physical switches. So that's kind of first line of defense. The second is we set software-defined networking ACLs where we can on the physical servers. So each one of those has a vSwitch, a Hyper-V virtual switch, and we set SDN ACLs as needed when VMs start and have an IP address that's managed by our network controller or the software-defined networking stack. So if I stand up a VM, if it's an infrastructure VM, we have firewall set internally to that, so we have another line of defense in the VM, and again, it'll have potentially a set of SDN ACLs in that as well. And then finally, we have essentially kind of one poke out so that HLH in the BMC network can be routed through the TORs as well. So obviously, you need to be able to manage the system essentially out of band, but the idea is that that would go to essentially a management network, or what we refer to typically as a corp network. So something that's not going to be exposed all the way through the firewall, but something that would be pushed off to the side, essentially, so it can be routed separately. It's one of the reasons why we asked for a different subnet for that, so you can route it more easily in the system. And I'll come back to the fact that Azure Stack only has 2 ways of providing address space for those user workloads. It's either through the site-to-site VPN, where I'm going to VPN into essentially a virtual network that's defined for the user content. The other is it's through the NAT or software load balancer. So if I have a virtual IP that's kind of a one-to-one mapping with a user virtual machine, that would be a NAT scenario. And if it's a software load balancing, say for a web server or scale-out web server, then it'll be kind of classic software load balancing. But those are the only 2 ways that we have to. The other alternative might be to do a forwarding gateway, and at this point in Azure Stack, we don't offer that capability. So I'll take a brief aside since I talked a little bit about security. A Can come back to the picture and let's talk about the points at where we kind of interact with from a secure standpoint. So we do secure boot and UEFI for each of the physical servers. That includes the ones that are carrying workload and the HLH. We're doing, Filippo and Jeffrey did a session, I think it was yesterday, can't remember exactly, that they talked about security, but we're using star authentication within the services and application whitelisting so that we lock down essentially what can be executed on the physical hosts and in our infrastructure virtual machines. Doing code integrity, anti-malware, and then for each of the virtual disks that we create that's riding on top of the space's direct configuration, we also have BitLocker enabled. So everything is encrypted at rest. Those keys are held within the solution, so those are essentially kind of solution-wide keys, but everything is encrypted at rest. So if you take a drive out, you're not going to have raw data on that content. We also do that on the hardware lifecycle host as well. So I'm going to come back to, this is a really old slide and a little out of date with the terminology, but it'll do for today. And I'm going to come back and talk a little bit about the network traversals and how packets flow through the network and what it means from essentially a performance standpoint. And again, coming back to the broader context of capacity planning. So this is the complex diagram of what the software-defined networking stack looks like in Windows Server 2016. So each of the columns or the larger host content at the middle of this diagram is the list of software-defined VLANs. So we have a management, transit, and HNV network, so that's where the encapsulation happens for the software-defined networking stack. So the idea is then have a packet that's outside of the network, so essentially at the top of the TOR, so it's coming inbound through the into the system. The first place that'll go through is what's we used to refer to as a transit network, but essentially if you remember back to the SLB diagram that I had where physical switches were exchanging BGP information about where to route to, essentially that 0 to 1 transition is that hop from physical switch to the SLB VM that's running in the infrastructure. So it flows across that network. That hop comes through the vSwitch of the, of the host. So there's an SD and ACL pass that happens right then. And then it's delivered to the SLB MUX. So the SLB MUX at this point is acting as a router, picks up that packet, identifies the destination, encapsulates it in VXLAN, and pushes it back out onto the physical network on the HNV subnet. In the current diagrams, that would be the infrastructure subnet. Now it's going to be delivered back up through the next vSwitch, and then eventually to the tenant VM is that path. So that's what happens on the inbound path. So that you can see that since we're essentially bouncing through a software gateway at that point, that there's going to be a performance impact. Now we've done all the right tuning and we've expanded, we're doing RSS in the VM for receive side scaling. We're doing all the offloads in the NICs. That's one of the reasons why we have requirements on the physical NICs to get the best performance we can. But going through that SLB MUX means that there will be, you're not going to run at line rate for the networking. There's going to be some impact. So if you're essentially pulling large amounts of data through the system, and it's going to come through that virtual IP for a workload, then it's going to be passing through that SLB MUX. So if I think about outbound, we've taken some optimizations with outbound because the software-defined networking stack keeps track of essentially, is it an internal address or is it an external address, and how does it manage that? So if it's just a classic VIP, so if it's doing that net MUX functionality, so we start up in the tenant VM, its destination is somewhere outside of the solution, so it's an IP address that's not contained with any of the virtual networks. It's going to go through the vSwitch in the host, and at that point, we recognize that it's going to route off of solution, and we actually rewrite the packet so that it goes directly on the physical network and up to the physical switches. So it goes on the network and then directly to the physical switches. So we skipped that step of going through the SLB MUX. So northbound traffic is going to perform extremely well. So we'll do just the best, the shortest path that we can in those traversals. And then if we're talking east-west, so I have two VMs that are either in the same subscription, their own VNet, or if I have two VMs that are essentially routing between themselves in the configuration, What happens there is that we start at the tenant VM, go through the vSwitch. At this point, we do another optimization so that we don't go through the SLB or routing step. So it rewrites it such that it, in VXLAN, puts it on the HMV network. It comes right back up to the vSwitch and right to the VM itself. So east-west traffic will perform reasonably well at that point as well. So let's switch gears a little bit and talk about storage. So let's go back. So in Azure Stack, we have, it aligns with what Azure does, right? So they have networking, VM or IaaS, compute capabilities, and then storage. And storage, at least for today, for consistency, that means that we can do storage accounts, page, and block blobs, tables, and queues. And then those stand up on top of essentially a set of services that run within Azure Stack. So there's a couple of VMs that manage those storage accounts, placement, and the overall namespace for that content, and then interacts with the other compute and networking providers to essentially, when you create an IaaS VM, you need all three of those resources, and the storage side will actually provide the disk that's attached to the VM itself. As you would expect, all that content then resides on a set of virtual disks that are in the infrastructure, so that's what we're running on top of Spaces Direct at that point. And then that's important because as we talk about the attached disks, the placement's important for us, and I'll come back to kind of how placement works and what that means for capacity planning and scale. So just briefly, so I skipped over it real quickly. So all the Azure consistent storage features right on top of the SMB3 are essentially that Spaces Direct fabric running on in the Azure Stack solution. So those are essentially clustered file system paths that get used. So this stack represents what we're doing. So virtual machines attached to, through the help of the Azure Consistent Storage Services, I'll take a page blob, I'll treat it like a disk that's attached to a VM through Hyper-V. So when that page blob is actually a VHD container, if you're familiar with it, and we just directly attach it to the Hyper-V VM. That's residing on top of an REFS file system in Azure Stack, so that means that we're using BitLocker in combination with REFS, which then resides on top of Spaces, and then the Spaces Direct capability of projecting each of the disks across the software storage bus. So that's the stack that we're on top of. So we're doing mirrored spaces within Spaces Direct. So we're doing a three-way mirror so that we get the best resiliency in the configuration and the best performance. And this is just a quick diagram. If you have gone to any of the Spaces Direct talks, so Cosmos Darwin, I stole this from him. So it's essentially just talking about how we're splitting up 256 megabyte chunks in this example, placing them across physical devices within a set of servers to accomplish essentially that three-way mirror capability. So we're doing primary and two copies in the configuration, just like any classic storage system would. And just to briefly go over kind of some of the failure examples and things that we protect against in the context of Spaces Direct. So if I have a 4-server system, these are the types of failures we can take. I can do a single disk failure. Obviously, we can take and we'll rebuild. And it turns out that we reserve enough capacity in the system to rebuild a single capacity drive. So you can think of like if I have a 4-server configuration and they're filled with 4 terabyte disks, we save, say it's a 4-server configuration, we save roughly 16 terabytes of storage in the overall pool. That allows us to, if a disk fails in any one server, then I can essentially reallocate that content someplace else. And so I can rebuild immediately when that disk is marked as failed. We'll go ahead and start to rebuild and recover the content within the system. So I'll protect against single disk failure. I can deal with a single server and 1 disk failure in the 3-way mirror configuration. Obviously, a single server failure, if I have 2 disks fail through in 2 different servers, and then finally, there we go. If I have 2 servers with multiple disks failed, as long as the servers stay up and run or are part of the cluster, then Spaces Direct will protect against that. So the things that we provision initially for Azure Stack, the virtual disks that we use are We have a set of 3 that get used for infrastructure. So everything within Azure Stack except the base level hosts that provide Hyper-V, Spaces Direct, and the base level SDN stack. Everything else in Azure Stack runs as a virtual machine. And all of those VHDs are hosted within the solution itself, except with the exception of 2 or 3. And if you're interested after the talk, I'll describe that to you. But we have everything else is a VHD on those infrastructure virtual disks. And so we have 3 of those for services that may have 2 or 3 VMs that are running for resiliency. We spread those across that infrastructure set. Then we configure the rest of the storage for essentially everything that's used by the user space VMs or the tenants that come into the solution. So that means that we have temp disks for each of the VMs. So we have virtual disks for those. And then all the data that's managed by Azure Consistent Storage. So all the page and block blobs and everything else land on tenant virtual disks. The idea is that when we get to the point where we're adding the capability for add servers, so I can scale vertically, then when I add a server, I'll add a temporary virtual disk and essentially a tenant virtual disk as well. So that's how we expand capacity. And that will be done automatically for you as a customer. And as you remember, we need, like I said, 2 cache devices and a minimum of 4 capacity devices. Some of the configurations are larger. So if we go back and review just kind of what the scale of resiliency is, then we can handle a single switch failure. So if one of the 2 data switches fails, we have the paths to actually continue functioning. We can deal with a single server failure, and then I just described all the disk failures that we can do, and then obviously, since we have a 2 PDU requirement for each of the servers, if one of those fails, then the server will stay up and run. So I'm gonna go back to this picture and point out that the disks down below are actually the capacity drives in the configuration. So when we create virtual disks, all of the capacity devices, so in a traditional hybrid storage configuration, all of the hard disk drives represent the capacity that is in the virtual disks, which is what Spaces sees, and then ultimately what the Azure Consistent Storage Stack sees. So what's not in this diagram is the set of cache devices that are used in the configuration. So I stole another diagram from Cosmos, since he does such a good job of describing it. So this is what really is happening underneath, meaning that even though all those devices are in the system, storage spaces only sees the capacity devices for placement of the data. It's storage spaces direct, and there's a caching layer that's in place that uses the flash devices as a write back and read cache for the capacity devices in each server. So if you think of the either left or right in this example as a single server, those cache devices are fronting those capacity devices. So each read and write flows through that cache as it functions. And that's important from a capacity planning standpoint because you have to think about if you want flash-like performance for Azure Stack, you have to size that flash layer to be large enough to capture the working set of the applications. So it's important for you to kind of understand what the layout's going to be and how that gets used. And it turns out since the capacity devices are the ones that storage spaces sees, the cache content is actually a divide by 3 in the 3-way mirror configuration. So you have to take that into account as well. You don't get all of the capacity in the configuration, if you can think of it as kind of a caching layer. Those are divided by 3, meaning that as I write 3 copies of data, 1 to each server, I'm going to have 3 copies in those cache devices as well. So from a capacity standpoint, it'll be a by 3. So I've talked a little bit about the caching layer, its impact on kind of sizing, so need to make sure that it's in the right working set. The other thing that happens because of the way Azure Consistent Storage works, it will group data together in what's referred to as a container. So I have a storage account, I can create a page blob, and I associate that with a container within that storage account overall. So this diagram is meant to capture the fact that I have one VM at the top that has 3 VHD files that are attached as disks, and they're contained within one container. What Azure Consistent Storage does for placement is it will put a container on a single virtual disk. It doesn't try to spread that across virtual disks. So that means that if you put multiple VHDs or page blobs into a single container, then they're going to co-locate on a single virtual disk. And so if there are performance or implications, there will be performance implications of that. I mean that it's going to be restricted potentially to going through one server with the way Spaces Direct works, and redirection. So if I build that out, then I have essentially the example of like I have multiple VHDs and contained with each container. But you as a user of Azure and Azure Stack, you have the opportunity to associate a single VHD with one container. So you can actually break that association if you want. So if I have 3 VHDs in a single container, switch diagrams, then I can split those apart so that I have 3 containers, containing 1 VHD each. And at that point, Azure Consistent Storage can, because it's doing essentially container placement, can start placing those across all of the file systems or virtual disks in this system. So you get much better scalability. So the idea is just like any classic storage stack, you can get better performance by attaching multiple disks into the VM, and if I put them in the right container associations, then I can spread the underlying physical placement as well in the configuration. So that's important to keep in mind. Again, if I look at application behavior, if I go back to kind of capacity planning, one of the stories I'll get here towards the end is the fact that really need to start the application so you have an idea of kind of the VM sizing, storage sizing for the solution, and then once you start essentially doing proof of concepts in Azure, if you have applications Azure, if you can keep in mind the design patterns that align well with the implementation choices we made in Azure Stack, then that transition will go much more easily, right? So you won't have to go back and rewrite the templates for your workloads. The placement will work both in Azure and in Azure Stack, and the performance will be the best it can be in both places. So capacity planning. So this is my normal joke of, is the way you do your capacity planning is I take servers, amount of memory, divide by the VMs, and it's like the answer is, no, but what would the answer be? It would be 42. You get the reference. But the problem is that capacity planning is like the old, anecdote about, if you take 10 people and blindfold them and have them, each pick a different part, stand them next to a different part of the elephant, they're going to describe something that are very different, right? Between the nose and the tail and the leg, et cetera. The same thing goes along with capacity planning, effectively in my mindset, because I've spent, a couple decades doing performance work and everything else, and everybody has their focus. It's like, oh, is it the network? Is it storage? Do I have the right kind of CPUs aligned? Well, it's actually all of those things when it comes to capacity and performance planning. And if you've noticed at the top of this, I bolded the fact that you really, in the context of Azure Stack, really do need to start with the application layer. You need to start with the vision in mind about how am I going to build this out? What are the features that I need in the function? As I've kind of touched on each one of these through the scenarios, not so much the memory and CPU cores yet, I'll get to that in a minute. But NIC speeds are important, right? I talked about the fact that we're going to subdivide that into a 50-50 between storage and what's going to get used for tenant. So eventually, if you get to the point where you really need a lot more network capacity in the configuration, you have to be aware of what the physical devices are capable of and whether you need to go work with our solution partners to understand whether you need to have something that will be at a higher data rate. So for example, I expect to see all flash configurations have something better than 10 gig networking, is my expectation, just because I'll be able to push more data across that from a storage standpoint. You want to get the best network configuration in place. What types of flash do I do NVMEs or SATA SSDs? They perform very differently. SATA SSDs are fantastic. They perform extremely well. And for a lot of workloads, they're just fine, right? But NVMe actually might be a better choice because I may have a different capacity capability or performance capability with the NVMe drives in the space. But you have to go back and think about the comments I made about Spaces Direct and the way it uses those devices for caching, because it's not only the device types and their individual performance capabilities, but how big they are from a capacity standpoint, and whether they're going to be able to effectively capture the working set of the applications you have running in the system. Because if I'm running in an Azure Stack environment, all of that storage I/O is essentially blended together. There's no strong association, say, with sequential workloads when you're mixing them with random I/O workloads, right? It's all going to turn into random I/O when it hits the devices underneath in, say, Spaces Direct or storage spaces. So you have to kind of keep that in mind in choosing essentially flash capacities in a way that capture those active workloads. Then overall storage capacities as well. I mean, it may be that a storage or a configuration has more capacity than you need, but the number of devices may be important to you. If I really start bleeding over the flash in the configuration, or if I can't afford that, then I may need more hard disk configuration or hard disk in that configuration to run. Or I may be able to trade off eventually storage capacity for performance if I get to the point where I need an all-flash configuration because I want to drop the latencies in the storage and not have to worry about the long tail of the storage configuration overall. So you really have to kind of look at the overall picture, but the application set is really where to start. So the capacity planning spreadsheet that I'll show you in just a few minutes captures all the details about storage configuration. So it will let you know what the available formatted capacity is for the system. It will also account for the infrastructure VMs I talked about. So everything that we run in the system from an infrastructure standpoint is encapsulated in that. So in this example, just to quickly illustrate, is that we run some of that infrastructure on the 4 servers. As I mentioned, we also hold back some capacity for patch and update. So we can live migrate VMs around within the system so we can try to keep them up and running. So we hold a little bit back for that, and then the rest of it's left over for the tenant or user capacity in the system. So it turns out that that infrastructure services, that does not scale with the number of servers currently. So meaning that if I go 4 to 12 servers, the amount of VMs and the size of those VMs, et cetera, stays the same presently. So you get a better efficiency, right, if you go to 12 servers than you would with 4 from a capacity standpoint. Now, it may be that in a few months that we get to the point where we're scaling, for example, I don't know, the SLB, so we're spreading out the amount of workload that we can capture from the network standpoint. Then we may add a VM or two to the system, but it shouldn't be significant, and it'll very likely scale with the number of servers in the configuration. So just to give you an idea of what some of the infrastructure roles are, I'm not going to go through and describe all these, but this gives you a sense that many of these are running 2 or 3 VMs depending on what the service is and how it's built. So we do consume, and there's a lot of content right there to provide consistency with Azure, so it's important for us to stand that up. So the VM list size that we have, this has expanded since the last time I was here. So with this is one table. It was too big to fit on a slide, so I split it in half. So this is the list that we'll have at initial release of the VMs. What I want to focus on, though, is so this is an IOPS statement. So one of the things that we've done recently to align with Azure is to cap the number of IOPS that the VMs can generate on individual disks. So these numbers align with what Azure does, generally speaking. I'll describe the discrepancy in a minute. But you'll notice that on these smaller VMs, so like basic and standard A's, they're either 300 or 500 IOPS per attached disk, where some of the Ds and DV2 sizes or DS sizes start to get IOP numbers that are much larger. So if you, again, looking at application deployment, if you're looking for an application performance from a storage standpoint, then you need to pick the VM size that best aligns with the IOP caps that are in place. So you have to think about looking at that portion of it too. So the other thing that we do in Azure Azure Stack I don't have captured is that we cap the outbound network throughput for VMs, and those numbers scale based on the type of VM. So A's will have less outbound throughput than, say, D or DV2s. I doubt that you run into those throughput numbers, but they are capped. And the purpose of this and the network caps is to try to deal with noisy neighbor issues, right? So I don't want to have one VM or one user that consumes a majority of the resources in the system just because they have a runaway VM, right? So this is meant to capture that. But again, you have to kind of be aware of it as you capacity plan. So let's see, I think I've talked most about this. So yeah, application behaviors. All right. So let me drive spreadsheet a little bit. Let me do this real quick. So these are all the other sessions. I know it's Thursday, but it's a good reference for all the content that we've presented. We go through all the details of Azure Stack and present it in a way that, so when the sessions get posted or the slides get posted, you can use this as a reference to go find those quickly. There are still some sessions, like I said, Thomas Rodinger has a session for the data center integration, so that's a good plug. Justin just finished his last patch and update session, so you'll have to catch that on the replay. Okay, so let's switch over to, so this is the current version of the sizing spreadsheet. So I'm just going to walk through and give you a sense of kind of what's there and how this will work or what you'll look at. It'll give you a sense, and hopefully this will stay up and run. So the first thing is this sheet captures example server configurations or solution configurations. So the idea is that you're going to make a choice based on potentially the capacity of two similar configurations. You're trying to figure out like, oh, do I buy a set of servers with less memory than more? Do I add more servers in a configuration to try to get better storage capacity? How do I change the CPU or memory scale based on that? And so the intent here is this allows you to kind of do a few what ifs, right? It's like, oh, what if I went and bought a 512 gig memory server versus 768? Or if I dropped the storage device capacities from, say, 6 terabytes to 4 terabytes to save some money, how much overall capacity do I get in the system, and does it fit the workloads that I have? So the idea is that you go through and you can fill this in, so you can pick the CPU type, which SKU gives you the number of cores, the amount of memory, and then the cache device sizes, and ultimately hidden down below here is the number of servers. So this is just the essentially range of servers that you have in this set. So if I go to just the basic, like, oh, I want to, now that I have that as input, the idea is that I can go through and pick some VMs based on their SKU. And this table, sorry for the interruption there. So it gives you the VM SKU from Azure. It captures the number of CPU cores. So this is the vCPUs that are assigned in the Azure SKU, the amount of memory that's assigned to that VM, the local temp storage that's there by default, and then total VM storage. Now the total VM storage is a value that you can put in. So the first three columns are defined by the VM SKU. The disk size is always your choice. So you can do a 128 gig disk, or you can do something larger or smaller. For right now, these are just kind of representations, so it gives you an idea that you're essentially is like, well, I may have 4 disks and they're each 128 gig, so it means I need to define a VM SKU here that's a 512 gig storage. So it just gives you the basics. Off to the right here is a set of graphs that determine capacity. At the moment, I have zeros for all those VMs, so everything's available. So everything is blue. So I have the 5 SKUs up here at the top that were on a previous sheet. So I have my 5 examples. It took that as input, and I have the 5 SKUs that are lined up here. And so when I start putting VM counts in, so let's say that I want to do, say 10 standard A2s, and I'm going to run a couple of larger A7s because they're big memory systems. And then I'm going to get some better storage performance, so let's go pick a DS3, and I'm going to put 3 of those in the system. So those are the capacities. Let me add one more just to, as an example I want to show you. So if I go back over based on those VM counts and look at the tables now, or the graphs, sorry. Get it to line up. So over here on the right-hand table, so it's available memory per SKU. So the orange now represents what's being consumed out of the total solution. So the number of servers have been gathered up, all the infrastructure requirements, the VMs and the holdback for patch and update have been built into this. And so the orange represents what the tenant workloads are consuming, and then the blue represents what's left over. So it's obvious now that, say SKU 1, which is a little bit smaller, I'm probably average on memory consumption, but the CPU core count's essentially over-provisioned at this point. So one of the things that feedback here is, on my side is that the over-subscription ratio for CPU isn't captured, but I'll do that here in a bit. You can also get a sense of kind of where the temp disk and the storage is being consumed as well. So again, you have an idea of kind of what's going to be consumed with this workload, and then if you're going to doing future capacity planning, you get a sense of kind of how it grows over time as it moves up. So that's just a quick overview. So the other tab here that you have an option, so as I kept saying, capacity should really start with the application workload. So in this tab, the approach is not just to list the VMs just by themselves, but to actually think about what the workload or application is for each one of those. And so in this sheet, So for example, workload 1 could be one of my applications, and I'm going to go ahead and it lists which VMs are being consumed. So A0s, A2s, there's a set of DS2s that are used. And down at the very bottom, I have essentially 2 instances of that application running. So you can think of it as like, oh, I have an application set. It has, say, a front-end tier and a back-end tier, and here's the VM sizes and the storage associated with that. I'm going to have 2 instances of those running in the system. And at the moment, I actually don't have anything else defined for workloads. So that means if I, again, scroll over to the right, and the same idea applies where it's like I have the capacities that are used, how much is left. And then at the very bottom, it shows, based on application, what the utilization is in the overall. So the donut graphs are actually showing what that is. So let's go back and add another application, just pretty quickly. So my second application, I'm going to have 3 instances of that. So the graphs update, and you get a feel then for capacity at this point. So at this point, it looks as though I've run out of storage capacity in the first 2 example configurations that I was running. So those are kind of off the list. And then the others are still there. And then I get a sense of also how much of the capacity is being used by each one of those applications. So I can get an idea of, am I really over pivoting on one application, its CPU consumption, for example, versus storage on another, so in the configuration. Mm-hmm.
How do you find out how much is the Azure overhead?
So the question is, how do you find the Azure overhead?
Azure is taking its own resources, right?
So does Azure take its own resources? So Azure Stack is unique in that we're actually running the infrastructure within the capacity you purchased as an end customer. In Azure, its infrastructure and the management of Azure generically are on servers that are not part of your domain. You have no idea what they are, how they scale, or they're actually not intermixed at all with, say, the compute and storage that exists in Azure. So in Azure, that overhead exists, but it's built into the overall cost structure of what Azure is providing to you. So the VM costs that you get, or storage costs, et cetera, those are all, that overhead is accounted for in the pricing, where this is more tenable, right? Because it is in Azure Stack as well accounted for in the pricing because you're buying hardware and we're using a portion of that for the infrastructure. But that's not really exposed to you as in Azure. And so that's also why if you look at the pricing of Azure Stack, the prices for vCPU and storage are much reduced from what Azure charges today. So with the idea that you're buying the hardware, you're running it, you're operating it, and you have to deal with all that, and so that's overhead that you're taking on, and part of that is essentially, again, is the infrastructure cost that we're implying, or burdening you with that as well. So, okay. So with that, I think that was the end of what I wanted to cover with the spreadsheet, et cetera. So if there are questions or other questions. Mike, if it would be helpful, so I don't have to repeat. Mike, you're right there. You have to pick up the mic.
Is this calculator available on Azure.com?
No, it's not available yet. Our intent is to make it available sometime in the month of October. We don't have a schedule set for it, but we'd like to get it out so people can use it as a way to rationalize what we're doing. So we'll get that out. Oh, he's at the mic. He gets to go next.
Yeah. So if you look at the current, it's just a single scale-out unit that you can use, and everything within the scale-out unit has to be the same configuration. But in the future, you can have multiple scale units. Can there be multiple different configurations, and can I then somehow control on what scale unit my workload will land?
Okay, so so let me rephrase that question. So as we mature Azure Stack and we add the ability to have multiple scale units within, say, a region or multiple regions, will you as a customer be able to buy different hardware, and then how would essentially applications be placed at the right differentiated hardware side? Does that sound right?
Yeah.
So that's actually the model. You can think of it as it's exactly the same as what Azure does. So today, Azure has, I think it's like 5 or 6 different generations of hardware in place, and storage is very different. And they deal with that through different VM SKUs. So for example, the N-series GPU SKUs will only be placed on servers, obviously, that have GPUs in place. But the basic A VMs, for example, will never land on a GPU-enabled system because it's too expensive. So they do that placement through or association through VM SKU to hardware is how they kind of, you can think of the placement being done that way. So in Azure Stack, we'll take the same model. So when we get to the point where we're doing multiple scale units, then each of those scale units, there's two reasons why you want to have different hardware. One is that there's generational hardware. So Intel releases a new processor, new servers come out. The old servers are either old and crusty or not available. So I have a different capability. So that's one reason why you'd want to do that. You want to put maybe the more performance-hungry VMs on those scale units.
Licensing.
Right, and then the other would be the example I just gave about GPUs. So if I'm going to have a scale unit that's going to have GPUs enabled, then I would place just those VMs in that scale unit. And so when we get to that point, that's one of the requirements that we have to meet. So we'll be able to do that differentiated placement, and we will allow for different generations or capabilities in the hardware as well.
So that me as a user in the ARM portal, I can just say I want to deploy my workload on that scale unit?
So we haven't worked through what the real architecture and gestures are for that, meaning that at the very basic, it would be that I just have the VM SKUs, and when you stand up a new scale unit, you'd say, here are the VM types that I want to allow on the system, and either it'll be based on hardware capability or your policy, your business policy. But beyond that, I'm not sure that we have a clear idea of what it's going to look like.
Right, thank you.
And you get a t-shirt. So you do as well. So you asked 2 questions. Next question.
Do you have any numbers from all SSD unit, and maybe included in the resource calculator?
So we have, we have our own numbers. So that's actually one of the things, and I think appreciate you asking, because that's one of the things that eventually we want to get into the capacity calculations is what the storage performance is for a configuration. And ultimately, that really can only come from our solution partner because they own that configuration. They actually own publishing those results in a way that they're comfortable with. So Microsoft will never get into the business of doing that because it's just, we won't have the matching configs, and it doesn't make sense. But we do want to get there. We do have a couple of benchmarks that we've published through ARM templates. So we have like a bootstorm and an random IO workload that we run. And so you can actually download those and run them yourself today. And they're in our Azure Stack Quick Start templates that we have so they're there. And the intent is that we expand those over time, and so the partners can choose to use those, and maybe we can mature the sizing spreadsheet to accommodate that as well. I will make the comment, though, that we do have a self-created all-flash configuration in the lab. So in a 4-server configuration with BitLocker turned on and an all-read, so essentially the best case scenario, random reads like x84 or 8K, we're getting about 500,000 IOPS in that configuration. So just to give you some scale, some reference of scale.
Sure.
Yep. Oh, over there.
So does the caching support 3 tiers of storage if you have NVMe, SSD, and spinning disk?
So the question is, 3 tiers of storage. So Spaces Direct generically supports 3 tiers. You can manually configure that. And Azure Stack, we do not. So we only do a 2-tier storage. And I want to be careful because we also do not support, say, an all NVMe configuration at this point. So it has to be either NVMe and SATA or SAS, or a SATA SSD and a SATA hard drive config. So, over here.
Yeah, the ERCS on the Azure Stack development kit, is that going to be available on regular and exposed on the regular deployment of Azure Stack?
Right, so your question is about the emergency console,
yeah.
is one's names for it. The other name that is getting used is privileged endpoint.
Yeah.
So yes, it will be in the product. So meaning that it's an integral part of the way we will service Azure Stack. In a multi-server production environment, that will not generally be accessible on the network. So the network switch ACLs will lock access down. You actually have to go through the HLH and then to that endpoint to do any servicing work in the system. So that's the way that'll be constructed.
Cool.
So I have 1 t-shirt left.
Yeah, I was wondering if on the 3-way mirror, is that, can we assume that that's chassis aware?
So chassis is in server, or chassis is in if there's an external
SAS or whatever.
So
my 3 mirrors aren't all sitting in the same box.
So way the space of direct configurations that we use for Azure Stack are set up is that the server is the boundary for storage placement. So, meaning that if there's 3 copies, it'll actually go to 3 different servers. If that server happens to have, say, 2, in the worst case, like if somebody chose to do 2 JBODs attached to a server, then the local placement won't be differentiated, just as long as it's in the server itself is sufficient, because it's only a single copy out of the 3. So.
Okay. And is there standard place we can go to compare pricing on the Stack vCPU versus Azure?
Yes, we publish the pricing for Azure Stack. The vCPU and storage pricing is published on the Azure.com site.
And the names are standardized as far as?
Yes. Okay. Yeah, the naming that I have here is what you'll see in Azure. And actually, you'll see through the portal if you go to create a VM, will be those names. Cool. Thank you.
So just to clarify, you can build 4 to 12 physical servers per rack, and it's not expandable. You can't increase from 4 to 12 later once you put it on the floor.
So the initial release, we will not do server expansion within a scale unit. So we've been asking that customers do essentially their capacity planning for essentially an 8 months into the future. So whatever you think you're going to start with and use in that 8 or 9 months is what we'd like for you to purchase. At that point, we will be able to deliver the capability to add additional servers to that scale unit. So if you say you started at 8 and wanted to grow to 12, then at that point when we do a software update, we'll enable that capability. So that's something that's on our roadmap that we're working towards. It's just we don't have it right now in the initial release.
And then as of today, you can't expand the scale unit, right, to include additional racks, right?
No, that's right. And that at the moment is not on the add server scenario is definitively on the roadmap. Adding scale units and regions is something that we're prioritizing, but we don't know what the timeline is going to be.
Right, so as of now, kind of the workaround is you have to manage, these VMs are in this scale unit and those VMs are in that scale unit, and you have to shuffle them or move them or something.
Yeah, so if you were trying to create a
big environment,
2 different site to site or a scaled environment, you'd end up with 2 Azure Stack clouds.
That you manage separately.
Yeah, and you'd have to run those separately in the configuration. So.
And then what about replication from a scale, could you do one scale unit to another scale unit replication, or could you do scale unit to Azure Public replication?
So let me answer that backwards. So Azure Stack to Azure, you can do replication through the use of ASR is one that is enabled today. So I can take a VM, use ASR, and I can replicate that to Azure proper. ASR will not work, say, Azure Stack to Azure Stack Cloud. That's not, again, that's something that's on the list, but it's just not their initial release. If you have a more generic replication requirement, then the replication, just like backup, needs to be done in the tenant itself through either, a VM plugin or through other application mechanisms.
Right, so you could use the Hyper-V enabled.
No. It's a plugin in the guest itself, not in the Hyper-V host.
So your options is to just rely on the triple mirror within the scale set.
Yes, if your business.
If that's good enough, but or you could go to public cloud with ASR.
That's right.
Right, but if you wanted to do, if you're not willing to touch public cloud, then there's not an easy way to do.
There's not an automated way to do that today.
To do replication to a
so
different
for Windows Server you
location
could. So for Windows Server you could, if the bandwidth allowed, you could do something like sync replica.
Like kind of at the server and application level.
That's right. That's right. And Hector Lenara has had a session on kind of backup and DR in general, so he goes through a little more detail on the partners that we've been working with, I think are in that.
Right, which might mean third-party software. Or,
yeah, that's right. Yeah, because the same story applies for backup in general, so if you need to back up the content, then it's really a tenant-level discussion at that point. So Veeam, Commvault, et cetera, et cetera.
Anybody that you'd use to back up a Hyper-V.
That's right.
Yeah. Okay, thanks.
Mm-hmm. Yep.
Maybe it's too far in the future, but if you buy a stamp or a scale unit today, you would like to go to a multiple scale unit model in the future, do you start from scratch or can you expand?
So our intent is that from that initial deployment, you can expand in three vectors. One would be adding servers to that scale unit, adding scale units to the region,
Okay.
and then adding regions. So
So we don't have to wipe and start from scratch or something?
yeah, I'm gonna be careful here. So that's the growth path, and that's our architectural intent. We have to actually get to implementation, but there's nothing that we've looked at that would, if I need to add a scale unit, that would say that we have to go back and redeploy that initial scale unit.
Okay.
The exception is that if we were just discussing, if you buy 2 Azure Stack clouds and then hope later that you'll be able to merge those 2, that's not going to work.
Happen. Okay.
You'll have to choose one and wipe it and redeploy it as a new.
Yeah, the only really HA setup will be buy 2 separate stamps and then provision simultaneously the same application.
That's right.
Too, and
Yeah, exactly.
sync. Yeah.
Yep,
Okay.
that's right.
Thank you very much.
You bet. Anything else? Thanks for your time, everybody.